Alright, now we're going to talk about functions. We're going to look at graphs and determine if they're functions, and then we're going to look at function notation. So to begin with, let's look at our axes. Draw our axes. Alright, so you got the x-axis, the y-axis. Make sure to always label your axes and put the little arrows on them. Alright, so let's look at our first graph. Alright, a line. Now remember, the definition of a function was if we take one x value, it gets paired up with exactly one y value. Alright, so let's do it. If we take this x value right here, it gets paired up with this one y value right here to give you a point that lies on your graph. That's all you're doing. You're trying to figure out if this x value here has a y value that corresponds to it to give you a point on your graph. And it certainly does. It's whatever this y value is up here, the yellow point. So no matter where you take an x value, there is only one y value associated with that particular x value that pairs up with it to give you a point that lies on your graph. Hence, this particular graph here is definitely the graph of a function. Alright, so now what's the domain? Now the domain is the set of all x values that are being used to generate this particular graph. Well, in this case, it's every x value is being used. No matter where you take an x value, there is a corresponding y value that will give you a point on your graph. So the domain is all real numbers. So in interval notation, that would be negative infinity to infinity. Alright, so now let's look at the range. The range is the y values, the set of all y values that are being used to generate these points on your graph. Well, since this graph goes forever up and forever down, every single y value is being used. So again, the range in this particular case is negative infinity to infinity, all real numbers. So for this particular function, the domain and range are both all real numbers. Every x value and every y value is being used to generate the points on this graph. Alright, let's look at another one. Let's look at a parabola. Alright, so back to the definition. Is this a function? Well, if you take one x value, how many y values correspond to this one x value that will give you a point on your graph? Well, only one, this one right here. It'll give you that little spot right there on your graph. And if you take this x value, there's only one y value that corresponds to it to give you a point on your graph. Yes, one y value has two x values that corresponds to it, but that's not a problem because the definition said take one x value from the domain and it gets paired up with exactly one y value in the range. It just so happens that we've got two different x values that pair up with the same y value. That's okay. So this is the graph of a function. Now, what's the domain? Well, as the arrows state here, this thing continues to go forever to the right, forever to the left. Every x value is being used to generate a point on this graph. So the domain is negative infinity to infinity, all real numbers. Now what about the range? Well, the graph does not go below negative 2. Negative 2 is the lowest y value that is being used to generate points on this graph. Now every y value above negative 2 is being used because this graph goes forever up. So the range would be negative 2, and notice the bracket because negative 2 is included, to infinity. Alright, let's look at another one. Alright, what about this graph? Alright, let's see if it's a function. If you take one x value, how many y values correspond to that one x value to give you a point on your graph? Well, if you take this x value, you've got a y value up here to give you a point, and you have a y value down here to give you a point. So you have one x value corresponding to two different y values. Hence, not a function. All you need is to find one x value that corresponds to more than one y value in order to not have a function. So not a function. Now the easiest way, when you have a graph, the easiest way to determine if you have a function or not is what's called the vertical line test. So if you draw these vertical lines through your graph, no matter where you draw a vertical line, if you only hit your graph one time, then you do have a function. If you find one vertical line that hits your graph more than one time, then you do not have a function. And we can see that right here. If you draw a vertical line, it hits your graph at 2 spots. Not a function. Back here with the parabola, when you draw your vertical lines, no matter where you draw a vertical line, it only hits your graph 1 time. So it is a function. So the vertical line test is the easy way to determine if your graph is the graph of a function. Now this thing may not be a function, but it's called a relation. So it still has a domain. The domain would be -4 to 4. Those are the x values being used. -4 to 4. Every x value in here is being used. And the range from -3 to 3 is being used. So we can still figure out the domain and range, even though it's not a function. Alright, that's the idea on if we have graphs of functions. So see the next video on function notation.